Hey guys, this is your video for your Forces Part 1 test. And so up above I've put the objectives. So these are the things that you need to know to do well on the test. And then I've gone through several questions to help you know that you're getting there. So to go through this, number one, what is a force? It's simply a push or pull. On this part of the study guide, I gave this to you guys word for word. I actually drew this entire table out, so I didn't feel like I needed to rewrite it down for you. So go to your notes. If you took them, you'll find it there. If not, you might be able to ask somebody to help you. So that's how that's going to go. And then number 3, do you always have to touch an object in order to exert a force? And explain. No, you do not always have to touch an object. Magnets affect objects without touching them. Static affects objects without touching them. Even air resistance. If I blow on a feather, I can keep it in the air, but I'm not touching it. Number 4, do normal forces always point up? No, they do not. They point perpendicular to whatever surface the object is on. Number 5, imagine you're leaning against a wall. Your body is in contact with how many surfaces? Obviously 2, the wall and the floor. So how many normal forces act on you? 2, because you're on 2 surfaces. And so how are they oriented? I drew a little picture here. Got the wall and the floor. So if you're on the floor, obviously you're going to have a normal force this direction. But if you're leaning on the wall, you also have a normal force this direction. So both of which perpendicular to the surface. And then how is the normal force acting on a truck stopped on a tilted ramp oriented? We had a review question about this. So I made a drawing to help show why this is the correct answer. Since the truck is on a surface that is slanted like this, the normal forces are also going to be slightly slanted, perpendicular to that surface. So if the surface looks like this, I want to be able to draw kind of part of an X out of it, and that's perpendicular. Number 7, what is an agent and what is a receiver? Well, an agent applies the force, and then a receiver is the one receiving it, so the one that feels the force. And these are some review from a worksheet that we did a few weeks ago, but you should still be able to do it. So for here, I knew that the force was gravity because the agent is Earth. The receiver is obviously the table. It keeps the table on the ground. This is my force arrow. Over here, it tells me my force is normal, so my agent has to be the branch, receiver is the owl, so the owl sits on the branch. Normal forces are perpendicular to the branch. Then, over here, my receiver is the jumper, and since the jumper is not in contact with anything, our only non-contact force is gravity, applied by the earth, which pulls the jumper down. Then over here, the 2 people are dancing, and if the receiver is the girl, she is in contact with the guy, so I picked applied. And the effect is that they dance together. He is pushing and pulling her. 3 things a force arrow can tell you are force, direction, and magnitude. I had several force arrows right up here. They told me what the force was, the direction of that force, and how large it is by drawing the length of the arrow. These next few questions, yes, I did repeat myself. Yes, it was on purpose. It's because that 9.8 number is so important. You have to remember it. So the force of gravity on Earth is 9.8, and the units are newtons per kilogram. Okay? So here and here, I wanted to make sure both of those things is asking for 9.8. Number 12, the amount of stuff an object contains is its mass. And then 13 again is 9.8, because I want you to review that and review it again. Number 14, newtons are the unit of force. Number 15, kilograms is the unit for mass. Refer back to that triangle that we had for gravity. In fact, it wouldn't hurt to maybe draw it out here somewhere. That would be a really good review for you. Number 16, mass stays the same on here, on the moon, anywhere else. Mass stays the same. Gravity is the thing that will change depending on where you are, which means that your weight changes depending on where you are. Okay? So if you were to measure your weight here on Earth, then again on the moon, would your weight be different? Yes, it would, because weight depends on the force of gravity. Number 19, the units for weight, mass, and gravity, I have them right there. Newtons, kilograms, and then newtons per kilogram. Very important. Number 20, I have a mass of 500 kilograms here on Earth. What is my mass on the moon? Well, if I have a mass of 500 on Earth, mass does not change. So my mass on the moon is the same, 500 kilograms. No math needed. You've got to read questions carefully, guys. I guarantee you there's going to be one on the test, and you need to be able to find it. Number 21, the Earth exerts a gravitational force of 600 newtons on Adam. What is his mass? So this would be where it would be really nice for you guys to have that triangle drawn somewhere. Even if it's right here, that's a really good place, actually. So you need to solve for mass. And we know that this is Fg because up here I said Fg is in newtons. So that's Fg. And we know that he's on the Earth, so 9.8 is our other number. So to solve for mass, I would take 600 divided by 9.8 because of the triangle, which hopefully you guys can figure out. And then my answer that I got is 61.2. And if it's mass, it needs to be in kilograms. Number 22, a box of cereal has a mass of 0.4 kilograms. What is the force of gravity on the box? Well, we are actually looking for Fg this time. But right here, we have a mass, and we're going to assume that it's on the Earth because it doesn't tell us otherwise. So we know 9.8 and 0.4, and we're looking for Fg, so we have to multiply. So 0.4 times 9.8 gives us 3.92. Since we're looking for Fg, we know that our unit should be newtons. 23, a force is a vector because it contains information about both magnitude and direction. We took notes on that last week. Number 24, total force. If two forces are acting in the same direction on an object, you need to add them together to figure out the total force. So here's the example I've drawn. You would add these two together. If they are acting in opposite directions, you would need to subtract because part of them cancels the other one out. So in this case, total force would be 3 newtons to the left. Letter C, if two forces are balanced, that means they are essentially canceling each other out from opposite directions. In that case, the object will either not move or continue what it was doing before because there's no force to change it. Number 25, if you want everybody to understand the forces on an object, what important pieces of information should you be sure to include? If you want me to understand what sort of force is going on, you need to tell me the direction that force is going and the strength of that force. So magnitude and direction. Here we've got some force diagrams. So remember, those are the ones that have the dot in the middle and you show all of the forces acting on the object. So in this case, our receiver is the jumper, so I circled her with a dotted line. And then the only force on her is gravity because she's in the air, not touching anything. Over here, our bookend was our receiver, and it's just sitting there. So gravity is on it, but it's on a surface, so we also have normal. And then a force diagram for the skier, dotted line around the skier. It's in the air, so only gravity. Then we have our sled, which is on a surface, it's being pulled, and it's moving. So we have gravity and normal, but we also have friction because there's movement. And the movement is going to the right, so the friction has to go to the left. And then the force that's causing the movement is actually tension from this rope right here, which is at an angle. The last page is kind of a cumulative situation, so it's one of those graphs that we spent so much time learning to do. So I'm expecting you to be able to do them still. So on the front, there are all the things that a good graph needs. So I've given you an example here of what this one should look like. Remember, you need a title. This is a label right here. These are labels. These are units. You need both on both sides. You need good scales. Mine are good because they go by the same increment every time. I skipped one box and I had 0.5. I skip another box, it's another 0.5. Up here, I determined this scale by that method I showed you. The highest number that I needed to get to in my table was 174. And then the number of lines on this graph is 10. So I divided those and I got 17.4. So I rounded it up to 18, and that told me I needed to go by 18s on this side, and that would give me the best graph. So then What I should have done was connected my dots using a ruler, but I didn't. But you should. And that gives me an excellent graph. Alright guys, the last thing I want to talk to you about is this part right here. Okay, the parent signature. This test is kind of large, and I want you to study for it. So, I'm giving you the opportunity for a few bonus points if you take this study guide home and have your parent or guardian sign it. It will give you a few bonus points on the test. The kind of requirement is that the study guide has to be completely done for you to get these extra credit points. So please have it completed. There's no reason you shouldn't because of this video. So get that done, have your parent or guardian sign it, and you'll have a few bonus points for some cushion on this test. And if you can do everything on this study guide, you'll be in good shape. So good luck, you guys.